Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is course schedule second. Well, if you have not done course schedule, which is the first problem, I would highly recommend you do it because this problem is exactly same, just with a little difference. That is, earlier we were returning if it's possible to take all the courses. This time we are going to return the order of the courses that we can take. Let's read the description again, but I'm telling you, like, I'll be reusing the exact same code that we had written for course schedule, and I will be just making those minor changes to this code, and then you'll see how easy it is to basically solve course schedule second. But we'll go through the problem again for the newcomers, or if you're trying to solve this one and you don't want to basically solve course one, but I would recommend you do that. Then you'll be able to solve it yourself, just like that. Okay, so there are total of num courses you have to take, labeled from 0 to num courses -1. You are given an array prerequisites where prerequisites A and B, they represent basically in order to take course A, you have to take course B. Now basically they have given this as an example, 0 and 1. To take course 0, you have to take course 1 before that. Now return the ordering of the courses you should be taking to finish all the courses. Well, there is not a particular one order you should be taking. If there were no dependencies, you could take all the courses in any order and you'll be fine. But if there are some prerequisites, then there is a certain order, and those order also could differ. Now if there are many valid answers, which will be written any of the orders. All right, well, let's see what we will be doing. Well, I will again ask you guys to just visit course schedule 1. I really went in detail visiting all the courses, creating the course map, the graph before we basically start exploring. Same thing we are going to do here, but if you watch that problem, you wouldn't need to do it or watch this. You will be able to write your solution by yourself. Well, anyway, let's dive deep in. So first thing, in this example we are given 5 courses. So there are 5 courses given to us. Then prerequisites represents 2 values, these pairs 0 and 1 here means that in order to take 0, I have to take 1 first. So this has been converted to basically adjacency list. This is our adjacency list. I'll call it graph. That will really help me basically traverse this graph using DFS. So I'll just have graph created for each 0, 1, 2, 3, 4, and 5. We have 5 courses, so 5 won't be there, I'm sorry. So 0 to 4. All right, so and next to each of these courses, we're going to have a list of all the neighboring nodes, or you can say prerequisite courses, that we have to take before we actually finish them. So for 0, we're going to go one by one. What are the neighbors of 0? Well, 1 is neighbor of 0, 2 is also neighbor of 0, then 1's neighbor is 3, 1's neighbor is also 4, then 2 does not have any neighbor, 3 has 4 as neighbor, 4 does not have any neighbor. So we'll have this list, basically graph. This graph is an adjacency list. All right, then we're going to start visiting basically all these courses, and in order we are visiting them, we will be basically in course schedule we will returning true if we were able to visit all the courses. Well, this time we will be tracking the order we are visiting, and if successful we will be returning that order. Right, so we're gonna have a course map which will store basically the Boolean value if we can visit those courses. So we're gonna have basically for 0, 1, 2, 3, and 4. All right, we'll be adding it like as we go along. but I've just written it for going through this quickly because we have done this already. So now let's say I'm going to start a for loop starting at 0 to num courses minus 1. So I'll start my basically iteration or traversal of this graph. So I'll start at 0. So let's say I'm visiting course 0. So while I'm visiting it in my course map, I'll mark this as false. And the reason is because I currently do not know if I'll be able to finish course 0. So I'll temporarily mark this course in my course map as false, that I cannot fully visit it. I will only mark it done when I have done all its prerequisites, and then I come back to it and then I will mark this true if possible, because there might be some dependency that might be pointing to 0, and while completing 0's prerequisites, one of the prerequisite has 0 as prerequisite, then becomes a cycle, then we can't complete it. So that is why I'll be marking it initially false. I'll be going to its first neighbor 1, and because I'm visiting 1, I'll mark 1 as false. 1 as false, currently being visited. Let's visit all its neighbors. First neighbor 3, I'm visiting 3. Because I'm visiting it, I'll mark this as false. Then 3 has neighbor 4. 4 we are visiting. 4 does not have neighbor. First I'm gonna mark it false, but I'm gonna start exploring its neighbors. Then there is no neighbor. Then I'll decide that this does not have any prerequisite. That means I could complete it. So I'll mark this true. Then I come back to 3. 3 only had one prerequisite. I have completed that, so 4 is completed. Then I go back to 3. 3 does not have any more prerequisite, so I'll change that false value that I assigned to it as true. And right here guys, like I will have something called, so this is of no use, so I'm just removing this. Like this was just to tell you guys, like these are the neighbors, right? These are the neighbors, so I'm just removing this. So we'll be traversing on the graph using this adjacency list, but like right now it's not of use. So what I'll do is I'll create course order list right here. So because I visited 4, it's fully visited, so when I'm marking this true, I'll also append it to my course order that I can take. All right, then I went back to 3. I'm also going to mark true, and when I mark this true, I'll also append it to my basically course order list. Then I come back to basically 1, where I called 3. So at 1, I have not fully explored all its neighbors. I'm going to try to access its second neighbor, but I'll see that it's already visited. Then that means I can also mark my course 1 as also completed course. So that means I can take it true. Okay, and then I will mark 1. I will append that to my course order. Then I will come back to 0, and at 0 I will see that all of its neighbors are not yet explored. There is another neighbor which is 2. I'm going to start exploring 2. At 2 initially I'll mark this as false, but then I'm gonna check all its neighbors, but doesn't have any neighbors, so I will change this value to true. So I'll change this to true, and because I've basically now fully visited this, and remember this one was visited, so I'll also mark this to my add this to my course order. Then finally I come back to 0, and then I'll change this also to true, and that is because I can visit it. I've visited all its prerequisites, so this can be safely visited. And then I'll also mark this, add this to my course order. Now this is what we will be returning. If in any case we were able to find a cycle, or like we could not visit any course, then we will be returning an empty array. So this is what we return. And as I said, we will be using the code that we have written for course schedule. It's gonna be very minor changes we will be making. So let's switch here. Okay, I'm gonna try to show you like the whole thing. Then this is the course schedule code that we wrote. So I'm just gonna copy it and we'll go over it. Time and space complexity we'll write ourselves. Okay, we'll go over this. So first, as I said, we'll be creating the graph, which is an adjacency list, and here we will append B to A because there is an outgoing edge from A to B. That means B is A's neighbor. All right, you can visit B from A. Once that's done, course map will create completed course here. We don't have to basically count the completed courses. What I'll do is change this to course order, and I will have this as an empty list. And then because here what we were doing is we were checking if we can do DFS. We'll increment basically this completed course. Well, we don't have a completed course. We will return empty array if DFS returns that we cannot complete that course. That means we cannot complete any of the courses. Return. We don't want to return like half completed courses. You don't want to drop out of your college, right? Yeah, please don't, unless you have a really cool startup idea. Well, anyway, here and then finally we can just return course order. And remember this DFS, let's explore this DFS. We are calling it on maybe like, you know, while going through this num courses, we'll be calling it on, let's say 0, and then you'll be exploring. We'll be initially marking it temporarily false. If this doesn't exist still in my course map, then you'll be exploring all the neighbors, and if you cannot visit those neighbors, you return false. Otherwise you basically mark that to true, and this is right here, my guys. You will be adding that course. This is where the magic happens. This course will be added to your course order, right? This will be added to your course order, and then finally you return this false value. Well, this course map is to basically track, like, you know, there is no cycle. Otherwise we didn't need it like that much, but like it really helps us like track those cycle, because if I mark this temporarily false, that means if any of the neighbor is basically any of the neighbor of this particular course while exploring this DFS here kind of like points back to this particular course, which we see in my right here course map, which I have marked false, so it will return false. And then if it returns false, we return false right here. If it returns false, we return basically empty list. That is it. Okay, let's try it. I'm gonna run it. Awesome. Let's submit. Beautiful. All right, so let's write down the time complexity. We can copy that also from course schedule, but like it's a simple thing. Time complexity is going to be big of v plus e vertices plus edges, because DFS will be exploring all the courses. We are maintaining like a map, so we will be not doing any cycle or repeated work, right? So we are visiting v number of vertices and e number of edges, because that's how you are, you know, jumping from one course to another. And space complexity is going to be also big of v plus e. All right, because you're storing it in your you know, we're creating this graph, and also we have this course map, so at both places we are storing that. And also we have, so the course order is now also a list that will be storing the order. So let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Bye bye.